Hey everybody, I'm Vanessa Little, and hopefully they have my deck up there in the booth, and I'm going to be talking to you about our proof of concept framework. So I work for VMware, and I'm currently a member of the OSM steering committee. At VMware, I'm the director of Integrated NFV Solutions, and I run a few innovation labs, specifically focused on integrating VNF partners, orchestrators, etc. with the VMware platform. So an OSM proof of concept. We're really encouraging members of the community to start building and designing proof of concepts that leverage different VNFs on different Vim layers for specific use cases, and packaging those up as proper proof of concept demos that really showcase the features and functionality of the platform as it evolves over time. We also use this as part of a feedback loop to influence the development of OSM going forward. And we really want to show being able to use open source MANO in real world use cases. So how would you actually deploy this in a customer environment? How would you actually deploy this in real life and make use of it as a production type scenario? And we really encourage multi-vendor and multi-component POCs. So instead of just one vendor going off and showcasing that they can use their VNF with OSM, we're really hoping that people are going to address a more holistic ecosystem type POC that you would see in a real world deployment. For example, if someone was really looking to do a VCPE type scenario, we would have one of the virtual router vendors get together with one of the virtual firewall vendors, with one of the virtual et cetera vendors, to showcase that you can service chain and insert new services into this scenario. And in effect, what you'll end up with is a proof of concept that shows that you can have multiple vendors existing on the same platform and existing in the same network service, all orchestrated by OSM. So what are the benefits of having an official OSM proof of concept? It's endorsed by the OSM community, and all of the members are exposed to it. It's centrally located on the OSM web portal, and so all of the OSM resources are contained within a central web portal, and these proof of concepts will be listed there as well. It's assigned an official POC number, and it gives you access to awards and recognition. There is an OSM Best New Feature Showcase Award, as well as industry events awards, like events like this one. There are a number of awards happening. The ceremony's on Wednesday, I believe. I don't remember if this particular event has proof of concept awards, but many of the industry events do have proof of concept awards that you could submit these demos and these proof of concepts for consideration in those awards, as well as various technology awards throughout the industry. Intel has a series of awards that they give out for various things. VMware has a series of awards that we give out for unique integrations, as well as a number of other companies throughout the industry. So how does one have an official OSM proof of concept? This is the criteria that you have to meet. You have to have at least one member that is an active OSM member or participant at the time you build the POC. You have to use the core OSM components. I think that one really goes without saying. And it has to be presented for comment to the OSM community. And then finally approved by the technical steering committee as a valid proof of concept that really leverages and showcases OSM as a solution. So the process to do this is not terribly complicated. You have to join Etsy OSM. At least one member of the team has to be a member of the community in order for this to be a recognized proof of concept. Send a formal POC proposal to the tech mailing list with a purpose to inform them that you have an intention to build a proof of concept and solicit feedback from the community. One of the reasons why we make this part of the process is what makes an open source community great is the community. And if someone has a proposal for a proof of concept that someone else might want to join or improve upon, we like to get that that early on in the process so that it becomes possible. What we want to avoid is people going off, building a proof of concept, polishing it, completing it, and then showing it to the community. We genuinely believe that the proof of concepts are stronger by exposing the whole community to them early on so that other people can jump on, support, and possibly make it better. The OSM Technical Steering Committee will acknowledge that we received the proposal and communicate that to the tech mailing list. So that's just part of our formal procedures. Then there's a suite of information that I'll talk about in a minute that needs to go to the MARCOM committee. That's our Marketing and Communications Committee, to make sure that this proof of concept is getting all the visibility that it needs. And you need to present the POC and whatever results to the tech community, be it either in one of our weekly tech sessions or at one of the OSM plenary sessions. And when you submit an OSM POC, there is an implied requirement that you're going to continue to keep up this POC as not only your solution continues to evolve. So if you're a VNF vendor, as you have new releases of your version, you're going to continue to integrate those new releases and those new versions of your software into this POC, as well as update the POC when OSM has new releases. And part of the presentation to the tech meeting is to showcase the video and the supporting documentation. It's not a requirement, but a lot of people like to issue a white paper at the end of their proof of concept that really showcases what it is that they achieved there, what the business case was for it, and how it benefits the community. And for more details, it's a little squashed here, but go to the OSM wiki to see the formal rules on the POC framework that I've touched on here. These are just the highlights. And so when you create this proposal package, it needs to contain a number of elements. It needs to have a title. It needs to list all of the team members, both the technical staff as well as the marketing team members, because the marketing is a very important aspect of these POCs. We want a short abstract, usually around 200 words or less, that really describes what the goal of this solution is, what use case it's addressing, and how it's addressing that use case. What the key takeaways are. So what is the message you're trying to get across with this POC? Is it that you can use open source MANO across distributed environments? Is it that you can use it across multiple VIMs? Is it that you can use it for security-based use cases? What are the 2 or 3 key takeaways that you really want people to walk away with after they've reviewed this POC? And then provide the POC technical overview in the official OSM PowerPoint template that's made available on the OSM wiki page. This is where you're able to present your technical architecture diagrams, your flow diagrams, all of those technical bits that normally go in your PowerPoint decks would go in this, and that we need you to include this in that package before you submit it. It doesn't have to have the final results of the build. It has to show the architecture of what you intend to build. And finally, we need to know which OSM version and which components you're leveraging. As the OSM project expands, certain POCs aren't going to focus on every little aspect of OSM, but we need to know at least which version you're using and which components are showcased in your proof of concept. And if you intend to show this proof of concept at any industry events or demos, we prefer that you let us know what those are so that we can get the marketing team on promoting those in social media and at the events that we participate at. So the marketing and communications team, as I mentioned, marketing is a huge part of what we're doing with these proof of concepts. On one side, there are the technical benefits to prove that OSM can do certain things and that it is a viable, deployable solution that can work in the community today. But aside from the obvious technical benefits, we also want to make sure that the companies that are participated are prominently showcased and getting the recognition that they deserve for having built this. And so we need to provide the following information to the marketing task force in order for them to assist in promoting this solution in the wild. The first of those is trademarks and permissions. And so if it's a commercial software solution that you've leveraged in this POC, for example, you work for Fortinet, and you want to use the Fortinet logo in your presentation videos, we need to make sure that that's been properly vetted with your marketing team, and you're allowed to do that. You're allowed to provide those logos in this collateral as associated with open source MANO. The licensing of the various components. OSM recognizes that not all of our community members are open source, and so if this POC is distributed or repeated anywhere, what are the licensing requirements in order to support that? Press releases and public notifications. We like to do a lot of things in social media and press, and we really prefer the POC participants to provide quotes that talk about what it is they've built here and why it's relevant to the industry. And then the various marketing programs. So what are your intentions for marketing this solution, if any? Are you going to put something on your company's corporate website? Are you going to distribute a video, be it on YouTube or on your other media channels? And what social media plans do you have to promote this solution, be it Twitter, Snapchat, whatever, or any other formal channels that your company may have? We'd like for you to communicate this to the marketing community within OSM prior to doing so, just to make sure that it's not conflicting or duplicating any efforts we already have happening. And then, what are you doing at various events? Which events do you plan to showcase this at? Will this demo appear in your company's booth? Will this demo appear on your company's website, et cetera, et cetera? So there are already 2 official OSM proof of concepts, the first of which was done earlier this year by Telenor, Arctos, Cisco, Intel, NetRounds, and Rift.io. And it really addressed DevOps and service chains and 5G network slices. I'm not going to go too deep into exactly what was built here, but I just wanted to highlight the fact that we do have one official POC that went through this process. They were the first one to vet the process and make sure that the process was valid and it didn't need any tweaks. But in doing so, what they've done is they've proved the process out. And they've given us a little more confidence in saying, okay, this is the process for submitting an OSM proof of concept. And here's one team that's already been through it. And they had a very successful video that's available on the OSM website if you're interested in seeing it. And it looks at some of the advanced orchestration capabilities to have full service assurance and SLA-based assurance of your deployed network services. So this is just a topology of that, of what they built there, where NetRounds is showcased here as the dark orange box is called VTA, and it's a VNF that's deployed at various points of your network that analyzes the traffic as it flows through it, and by doing so, it determines the health of your service. And so here you see that they've used various components from Cisco as the VNF under test, and they start pushing traffic through this network, and every time it crosses one of these VTA appliances, it analyzes things like latency, packet loss, round trip time, whether or not there's any jitter. And in being able to do that, you can not only determine where in your network you may be experiencing an issue, but also what that end-to-end user experience is. And so that's how they're able to determine whether or not you're violating your SLA. And they used open source MANO to deploy this whole stack, as well as push the configurations to the NetRounds and the Cisco components for the various service. And so if you're more interested into digging deeper into the POC number 1, these are the various URLs. This deck will be made available to you for download from the Layer 123 website, so don't worry about feverishly copying these things down. Or you can ask any member of the OSM steering committee that's here today, and we will give you all of the links that you need to the OSM website. So POC number 2, which is the next one that's based on OSM release 3, is leveraging the VMware Integrated Openstack VIM platform in multi-access edge computing scenarios. And we worked with Rift.io, Fortinet, and DataArt on building this. Additional software that we use that the companies who produce them didn't necessarily participate are the freeware FFmpeg video transcoder, the freeware Viata router, and the Ixia traffic simulator. So what we were really trying to achieve in this POC is to show OSM Release 3 as the orchestration solution to deploy and maintain edge servers in several different use cases. So what we wanted to show is that you can have distributed topology with a central data center and what we call micro data centers that are closer to the edge. You can use OSM to orchestrate various services across all of that infrastructure, and those services can be very diverse. So we've got fixed line as well as mobility-based services that leverage the same hardware infrastructure, the same virtualized infrastructure platform, but are very unique and very disjointed services. And so we look at video transcode at the network edge with FFmpeg. We used Fortinet as an S gateway in a vRAN edge scenario. We also overlaid an SD-WAN fabric across these multiple micro data centers using the Viata router. And then we also use some of the native VMware capabilities in our platform to deliver operational intelligence in these distributed architectures. All of these network services were templated, deployed, and operated by open source MANO Release 3. So this is the topology of the architecture that we built at a conceptual level. So you see at the top, we're showing our core data center. So this is where your management plane exists. This is where your FCAPS layer also exists. And so you'll see here on the left, we have the control plane for VMware Integrated Openstack, as well as the open source MANO deployment. Moving down the graphic here, we see we've got our 2 micro data centers. So these are our smaller deployment edge data centers. So they don't have a control plane. We've pushed only those compute components of the VMware Integrated OpenStack platform down to this edge, so it doesn't have the full OpenStack deployment there. It only has the Glance store and the Nova and Neutron, as well as NSX. So for those of you who aren't familiar with the VMware Integrated OpenStack platform, it doesn't use Open vSwitch. It uses NSX as that SDN layer, and so it exposes those Neutron libraries. So it's the same Neutron libraries you'd use to do any of your network programming. But instead of that translating into a configuration for Open vSwitch, it translates to a configuration for NSX. And so you'll see here that we've got the NSX distributed logical router and the edge router deployed at these micro data centers. And we push this NSX fabric across the multiple data centers so that we have a stretched layer 2 management plane. And that's how OSM is able to reach all of these various data centers in order to do those deployments. And you'll see here what we've done is we've pushed not only an Ixia appliance to simulate vRAN, but we've got the vRouter, we've got the Fortinet S gateway, we've got the video transcoder. They're all living in the same micro data center, and they're all segmented off from each other on separate network slices or network segments, depending on how you like to use the terminology. And all of this was orchestrated by open source MANO. So part 1 is where we showcase that you can configure the network and deploy across multiple data centers. And so we leveraged some of the new technology available in OpenStack Otaka that allows you to use different availability zones within OpenStack. So what we built here was each micro data center is a unique availability zone. And that's how we manage what gets deployed where. And we're able to do this through the OSM interface. Step 2, we deploy SD-WAN services. So we blueprint and template what that SD-WAN service needs to look like. So virtual router in one data center, virtual router in another data center. Then we push a netcom configuration to it that pins up that VPN tunnel between them. This could also be used to pin up a VPN tunnel to a remote site, for example, in robo-type scenarios, or if you wanted to use this as a VCP type scenario, that's how you would do this. The third part is we deployed dynamic video transcoding at the edge. So what we did was we created a virtual machine, and then we did the same thing as a container that contains FFmpeg with a bunch of specific scripts wrapped around it, and a small API interface where we can push configurations to say, we want you to transcode this video stream at the following bit rates. So this scenario is particularly relevant in MEC type scenarios because instead of backhauling all of that video transcode to your central data center, it stays closer to the edge. In mobile situations, this means you're staying closer to your towers or your eNode Bs. So if you have a localized event, for example, with a bunch of localized cameras, say, for example, at a stadium or a sporting event, all of that video transcode and dynamic manipulation for mobile is happening at the edge site, as opposed to taking all of that, HD or 4K video, pulling that all back to a central site, then transcoding and pushing that back out. It's next to impossible to monetize on that because of the bandwidth constraints, and the latency for that round trip video transcode is too long for it to be useful. But doing all of that at the edge is actually very valuable and very inexpensive. So that's what we were really hoping to showcase in this section of the demo. And then finally, we wanted to explore vRAN architectures. In a lab environment, this is really challenging because in order to truly do a vRAN architecture, you have to pin up your own local network with your own local cellular network. So you need access to small cell devices, as well as a license to use local spectrum in a certain localized area. Where this lab is located, that's extremely difficult to do, and we noticed that we were somewhat handcuffed by a lot of legislation and paperwork. So in order to get this demo in the can, what we did was we simulated the vRAN workloads using Ixia. I think for OSM Release 4, this might actually become a fully featured proper vRAN scenario where we actually build our own mobile localized network. But we need time for the paperwork to happen, obviously. But what we're really trying to show here is that you can push your RAN to the edge while also running in conjunction with things like video transcode, while also running in conjunction with things like SD-WAN. When we're talking about these micro data centers, we need to remember that this is a very small footprint. In this scenario, we're talking about 3 physical 1U servers. This footprint could get even smaller. We like to use 3 because we use a software-defined storage solution. It's a hyper-converged environment. But you could go as small as 1 node if you were able to sustain a failure at that particular data center and have your workload fail over to another data center. So when you're looking at edge computing, we're talking about very, very small bits of infrastructure that are capable of being extremely flexible. So that's really what we were trying to showcase here. So in addition to the formally recognized POCs, there are a number of demos that have been done with, at various points through the OSM lifecycle that I wanted to touch on a bit here. While these aren't officially recognized POCs, it's important to note that people have been doing integrations with OSM pretty much from day one, and there are a number of interesting use cases that they're already addressing. The first one of these was showcased at MO World Congress last year in Barcelona, and it was one built by 6Wind, Canonical, Indra, Intel, Metaswitch, Rift.io, and Telefonica, and it was really showing that type of end-to-end orchestration. So when you're looking at how long OSM's actually been a community, this is a pretty significant achievement for us to have a functional demo in February of last year. And that we were able to do end-to-end orchestration of a somewhat complex network environment where we had layer 3 routing across a distributed architecture, and we were able to use OSM to deploy an IMS service across a distributed data center architecture. And this is the demo topology of what we built. And so you see here we have the distributed network with the 3 PE routers in a multi-data center architecture with an SSL VPN that connects across them. And then at the bottom, you'll see that we have the Metaswitch IMS core that was deployed by OSM. The second of these demos showcased lifecycle management of VIMs. And this was done by XFlow Research and Metaswitch. What they did here, it was also an IMS solution, and it really showcased packaging and the freeware version of the Metaswitch IMS, which is known as Clearwater, templating, packaging, and managing the day 2 lifecycle management of that in an OSM environment. This was done with OSM Release 1. The third demo was integration of OSM into the public cloud. This was also done by XFlow Research. And what they did here was they showcased that you can use Amazon Web Services, AWS, as your target VIM with OSM. This was using OSM Release 2. And they also did a deep dive into the comparison of the AWS components versus core OpenStack components. So one of the challenges that we've really come up with, I wouldn't really say challenge, but one of the notions that we need to address in OSM as we keep integrating these various VIM layers is the realization that different VIMs do different things. Different VIMs have different capabilities. And originally, we were more focused on integrating with KVM-based OpenStack VIMs. We noticed that once we start to open up that ecosystem, we need to make sure that the orchestrator recognizes that certain VIMs can do certain things that others can't. And so part of onboarding AWS as one of the VIMs was to build up this comparison matrix of how it stacks up against traditional OpenStack environments, what you can do in a deployment scenario and what you can do, what parameters you're able to pass those virtual machines as opposed to what you can't, and how that compares to the OSM data model. It seems somewhat trivial to just say we can develop against the AWS VIM and push a workload to that. Those APIs are well known and there's sample code available on the internet. This should be a 2-day exercise, but really all of the heavy lifting was in how that fits into the broader OSM ecosystem. And it really had to, we really had to shift our mentality of what a VIM really is and how a VIM needs to be addressed by an orchestrator, as opposed to just saying, here's a suite of parameters that the VIM must support. Instead, it became more of a conversation of how does the orchestrator leverage all of those features that the VIM has available, and how does it fence off those features that it does not have available. The fourth demo that was done was done solely by RADCOM, and what they looked at was leveraging RADCOM vProbes and how to deploy a probe solution using OSM. So what's really relevant about this demo was that showing that you can use OSM for day 2 operations like probing and security analysis, as well as performance analysis. So we already had our network service that was deployed and it was running, and there's some kind of a problem that we need to find. What this demo showed was that you can use OSM to deploy a network service for probes onto an existing network service. That will let you analyze how it's doing, and then once you're done that analysis, you can undeploy the probes. So it really showcased that OSM plays a role in day 2 operations, not just for that day 0 pin up your service, but also through the lifecycle management and operational management of that network service. Demo number 5 was network services with integrated VNF verification. This was done by Ixia, Canonical, DataArt, and Sonos. And so what they looked at there was using the Sonos Session Border Controller software to operate across diverse virtualized infrastructure. It used the Ixia Phantom Virtual Tap for network visibility. It generated load using the Ixia load generation tools. And it showed how we package and model network services and lifecycle management using the Juju components of OSM. This was one of the more complex demos in that it had a lot of moving parts. but it was also one of the most valuable in that it showcased that day two operations and how to do the lifecycle management of a various VNF, as well as how to do a deeper inspection as to how that VNF is behaving and how it's working in that virtualized environment. So that said, do we have any questions from the audience about the OSM PoC framework or any of the PoCs or demos that we've done so far? Okay, that said, I will hand it off to Adrian to wrap up the day.